Hello and welcome back. I'm Matthew, this is Aaron, and this is the Arduino Quick Setup Guide, filmed here at the Visual World Investigate Lab, part of the North Carolina Museum of Natural Sciences in beautiful downtown Raleigh. Thank you for joining us. In this series, we have been talking about how to use this, one of our favorite little devices. This is called an Arduino. Now, what can you do with an Arduino? Well, you can use an Arduino to make almost anything that you can think of using a little bit of electronics and a little bit of computer programming. During the course of this series, we're assuming you've never used one of these before, that you've never done computer coding before, or electronics before, built circuits, and we're walking you through all those steps on how to get comfortable using these things and building whatever you can think of. Now, in the first few episodes, we got you used to how to use this and how to upload code to it and how to create some simple circuits with it. Now, we're going to create some more circuits using one of our favorite types of component, the sensor. Sensors are super cool because what you can do with them is use them to take recordings of something in the real world. And there are lots of different types. There are temperature sensors, gas sensors, there are motion sensors, there are microphones, there are light sensors. There's so many different types, and they all operate in kind of a similar way in that however they gather that data, however they detect that data, they then take that data and turn it into varying amounts of electricity that they send on to the Arduino. The Arduino measures that electricity, and then it's up to you in your code to decide what 1 volt means or 5 volt means. It could mean all sorts of things depending upon the type of sensor that you're using. So we're going to be covering 3 very common, very popular and fun sensors today. So what do you have up for us first?
Yeah, so let's start with a photoresistor. I will zoom in here on one for you. Get all these other sensors out of the way. So here is a breadboard. I'm going to put a photoresistor here across the middle. So a photoresistor, it's kind of this little pill-shaped looking thing with a squiggly line on top and 2 legs coming out the side. So there you can see both legs. And how these work, the top of this has a sensor that changes the resistance based on how much light's hitting it. So the more light that's hitting the photoresistor, the more resistance it will have. So it's kind of like those regular pill-shaped resistors you have in your kit, except it changes resistance based on light, which is why we call it a photoresistor. So the circuit for this is pretty easy. I'm going to bring over my Arduino, set that up, and we only need a few wires for this and a resistor. So I'm going to start off by doing one side over here. So on one of the legs, you're going to connect that up to the ground on your Arduino. So connect this up to ground. And on that same side, we're going to use a resistor. Connect one leg of the resistor in that same row, and then the other leg of the resistor in a different row. And we're going to use that resistor to connect up to a analog pin so we can read the amount of resistance that's going through the photoresistor. So basically we can see how much light is going through it. So to do that, on the same row as the other leg of that resistor, we're going to hook that up to A0, which is down here at the bottom of your Arduino in the analog pin sections. We've mainly used digital pins so far, so that's very handy. And then the last part, the other leg of the photoresistor, that is going to be connected up to the 5 volt pin on your Arduino. And that's our circuit. So now let's go on to code. And Matthew's going to walk you through the code. I think it's pretty simple for this one.
Great, that's right, Aaron. So, load up your Arduino IDE. Here, you'll start with a blank sketch. Here's the code that it starts you off with. We can go ahead and delete it all. We're not going to need it. We'll use parts of it, though. but we're going to start from the beginning. All right, so yes, this is going to be a very simple sketch. What we're going to do is take readings from the photoresistor and have them print out on the computer screen. So this is really cool because this will show you exactly what the light levels are like in the room that you're in. And this same technique can be applied to a lot of different types of sensors. So, since that's all it's going to do, we're just going to use we're just going to need one variable. So let's create a variable for the photoresistor. The photoresistor is going to report back integers, so we're going to use the int variable class. So int, and instead of typing out photoresistor, I'm just going to do PR. So PR and semicolon. We're not going to set this to equal anything because this PR is going to be the light value. This is something that's going to change. So, depending upon how much light is hitting it. So, done with the very beginning. Now we're going to move on to the setup. Void setup. Open parentheses, close parentheses, open curly bracket. In the setup here, we just need one thing. We just need to open up a communication port between the Arduino and the computer and tell it what speed to send that data in. There are different speeds that you can choose from. So, we start that using using serial with a capital S because it's a serial port that we're hooked up to. Serial.begin, this starts it, and then in parentheses is going to expect one parameter. This is the speed. We're going to use the default, most common speed of 9600. That's in kilobytes per second. And now we're done with the setup. So I'm just going to use my arrow key to get below that curly bracket. And now, onto the loop. Void loop, open parentheses, close parentheses, open curly bracket. Now here, we're just going to put three things. The first thing we're going to do is actually read the sensor and save that to our variable that we created. So we'll start with the variable name PR and set it equal to whatever is coming in from the port. So the statement that we use for that is called analog read. Because as Aaron had said, we're hooking up to one of the analog pins. And they're different from the digital in that they can not just detect electricity, but they can also detect the amount of electricity going to them. And since the photoresistor is a variable type of resistor, the amount of electricity it allows through it is going to change depending upon how much light is hitting it. So, analog read is going to expect one thing in parentheses, and that is which port you're listening to. Aaron hooked it up to A0, so I'm going to put A0 there and end it with a semicolon. Now, the next line is going to be the line where we actually tell it to send that data to the computer. We've opened up the communication line between the two, but now we need to tell it what data to send. So here we use another serial command, serial.print ln. I know it looks like a 1, but it's an ln. So that's short for print line. And that's going to expect one parameter, and that is what you want it to print. So you could put a lot of different things here, but we want it to print the light value, which is saved as PR. So PR in parentheses, and then semicolon. Print line, your other option for print line is just print, but what that will do is print out all the values on a single line, and that's going to be really hard to read. So this is going to print out the value on one line, and then go down to the next line, print it out again, and keep going. Now, it'll naturally do that very, very quickly. It might be a little hard to read. So we're going to put a small delay in there to not only make it a little easier to read, but also give the photoresistor a little bit of a chance to become accustomed to the new light level. So we're going to put a delay of just 50 there, and again, that's short for milliseconds. And that's it for the loop. We've already got the curly bracket here because it set it up there automatically, so we're going to leave that as it is. And now we're going to hook up our Arduino board to your computer and send it to it. All right, there's the happy little noise. I'm going to double check to make sure that it knows where the Arduino is, what port it's hooked up to, by going to Tools and then down here to Port. You can see it's detecting it here, but it doesn't select it. So I'm going to select COM4. You'll probably have a different COM port. And now it's happy with that. Now I can press the upload button. If you're doing this for the first time, it's going to ask you to save it somewhere. And we're just going to hit save there. You could name it if you'd like to. to give it a different name here. And now it's sending it to the board itself. And we're good. There it says done uploading, and we don't have any orange errors there. Now if I look at the board, I don't see anything unusual. I just see that the transmit light is completely lit up. It's actually blinking, we just can't see the blink. Now in order to see the values on your screen, what you need to do is come over here to the button in the top right hand corner that says Serial Monitor. So once you click that, it's going to bring up a screen, a new window, that looks like this. All right, now right now it is reporting all zeros. So let's see what happens if I add some extra light to it, if it changes. There we go. So there are a couple different things that will affect the amount of light, the values coming from the photoresistor. And that is, of course, the amount of light in the background, but also the resistor. So if you have a resistor, if you're not getting the values you want in the background, you might want to try changing out the resistor. Right now we have a 330, I believe a 300 ohm resistor, but you could also put a 10K resistor on there. That's very common. And then you'll get different values. It could be in the hundreds, it could be in the single digits. It all just depends upon which ones you use. So that's working. We could also look at this a different way. The numbers are really cool, but we could also pull up the plotter. So let's try that. Let's go to Tools and then Serial Plotter. Here's a serial monitor. That's what we just did. Serial Plotter will give us a really swanky graph. So here it is at 0. I'm going to bring in some light. And now we've got some new values here. And as I have the light go up and down, you can see the values changing. These little parts, these little photoresistors are really just a few cents each. I mean, you buy them in a pack, but they're really cool. As cheap as they are extremely sensitive. You can do some really, really fun things with them. We like them a lot. And in fact, in our final project, in the final episode of this series, we're going to be doing something really special with them. So you can look forward to that. So that's it for the photoresistor. Now we'll move on to another really cool type of sensor that you can do even more with, and is a lot more high tech. So what do you have up for us next, Aaron?
Okay. Our next sensor today is going to be a ultrasonic ping sensor. Here is a copy of it for you to look at. And you'll notice on the ping sensor that there are kind of two speaker looking things on the front. So it uses echolocation, kind of like a bat, using these two speakers. One of them will send out sound waves, and the other one will listen for them to echo off of something and come back, so it knows how far away something is. It's pretty easy. It only has 4 little pins at the bottom. It has lots of circuits on here, which makes it really easy to use because you only have to hook up 4 different pins to your Arduino. And on these pins, you'll see there's a ground pin, GND, a VCC pin on the other side, or that's for 5 volts. In the middle are echo and trigger pins. This has 4 pins. Some of these will only have 3 pins of these ultrasonic sensors, and those combine the echo and trigger pins into one. So it'll have a ground, a 5-volt pin, and then one other pin in the middle. And the code for that's a little different. You'll have to look that up. Hopefully it came with your sensor, tells you the difference. If not, you can look it up on Google or somewhere else on the internet. But today we're going to show you how to use this one. It's one of the most common sensors. So let's get our board hooked up here. So I'm going to start with ultrasonic sensor. My Arduino here behind it. Let's move this in a little closer for you to see. All right, so as I said before, there are 4 pins. The first I'm going to hook up is the ground pin. After I move the sensor one more time. Wasn't quite happy with it there. All right, so the ground pin, GND, hook that up to GND on your Arduino. Then next we're going to hook up VCC, and I'm using a red wire here to indicate that it has power or it's live, and that's going to go to the 5 volts on your Arduino. And then the last 2 are going to go to digital pins. So for this we have the echo pin. Here I'm using this wire, and the echo pin is going to go to digital pin number 4. Now, last time we used analog pins for our photoresistor. This time we're going back to digital pins. So these are just going to be on or off little pulses. So our last one we haven't done yet, the trigger pin, is going to go to digital pin number 2. Hooked all of that up. Move this in a little closer for you. All right, so that's the setup. It's pretty easy. And now we'll go to the code with Matthew, which is also fairly easy.
That's right. Yes, and what I think is remarkable about this sensor is that even though it's much more complicated than a photoresistor, it's much simpler to set up. And part of that reason is because, or the main part of that reason is because you saw on the back of it, it has microchips and resistors. All those things are built into it, so you don't have to add them on separately. So that's why all it needs is wires to hook up to the Arduino. And yet we're going to be able to do so much with that. So let's begin. The code is very similar to what we did with the photoresistor, with one major exception, and that is we need to bring in a library. So let me go ahead. This can take a moment, so I'm going to go ahead and bring it in while I talk about it. You go up to Sketch, and then Include Library, and then Manage Libraries. And then it might take it a couple minutes as it connects to the Arduino server to pull in all the different libraries that are available. So what is a library? A library is a package of code that someone else has written to make whatever you're trying to do easier. So technically, we could write all the code to communicate with that sonar sensor there, that ping sensor. However, it would require a fair amount. So in those instances, especially with common parts, people have created libraries that make it much, much, much simpler to work with them by creating functions that you can just call upon whenever you need to. So, but the first thing you need to do in your sketches is tell the sketch what library you want to include. Now, right off the bat, the library for this sensor isn't built into the Arduino program. The Arduino program has some libraries built into it, but not this one. However, this one is one that is easy to get. It's pulling up the library manager right now, and what we'll do from there is simply type in the name of the library. We'll be able to grab it and install it, and then use all of its functions. And while that's loading, still, let me go ahead and talk to you about what the sensor actually does. So it's a lot like echolocation, or it is like echolocation. The speaker will emit a pulse of sound that we cannot hear. And that pulse of sound is going to eventually, if there's something in front of it, bounce off of it and then come back to it in its direction. So one of those little speaker-looking things is a speaker, but the other one's actually a microphone. They're identical looking. And so it's the amount of time it takes for that ping to go out and come back that can give you an idea of how far away something is. And that's how bats and dolphins do echolocation as well. The sensor will send out the ping, and then it'll start a timer, and it'll count how long it takes for that ping to come back. And if it takes a long time, that means that something must have been far away. If it doesn't take very long, then it must have been pretty close. All right, so here I can see our manager has popped up. All right, so here it lists out of different libraries. Oh, it's actually still downloading them. And then from there is when we will type in the name. Okay, so updating the list. And then we'll install it. And so what can you do with this? Well, with the ping sensor, you can measure distance with it. But you can also make some really cool projects as well. So now everything's good to go. So I'm going to type in, the name of this library is new ping. So I'm going to type in new ping up here and then hit enter and then just wait for it to find it. Okay, here we go. So I typed in new ping and it found it. Mine already says install because I did this previously, but yours will not. So at that point, this button will be available and you'll be able to hit install. It'll take a couple moments. After it's installed, you'll get a little indication, a little check mark or something, and then you'll click close. And then after that, it's going to be immediately available to you. So let's then actually bring that into our sketch. So we'll go back to Sketch, include library, and then we'll go down this list. I'm using the scroll wheel on my mouse to get to contributed libraries. That is where all the libraries are that you've added. So there's new ping. I'll click on it, and there we go. So it added this line for me. This line is like a reference telling the Arduino, telling the sketch, telling the program where the library is. This is an actual file name. So it's telling it where it is, so it's going to read that before it reads any of your code, and then remember all the functions, all the in there, because you may be calling upon them, and we will. All right, so now after that, we need to tell it where the sensor is, what pins we've hooked the sensor up to. So we do that using a function from the library called new ping with a capital N and capital P. And then we're going to give our sensor a name. I'm just going to call it sonar. Then after that, it's going to expect three things, three parameters in parentheses. The first parameter it's going to expect is the trigger, where you've connected the trigger pin. So we connected it to 2. All right, and then it's going to expect, and then it wants to know where you've hooked up the echo pin. We hooked it up to 4. And lastly, we need to tell it what the maximum value is that it could be receiving. And this is something that you'd have to look up. However, I know that it's going to be 200. Semicolon. And what I like to do for something like this where you might not remember exactly what these numbers are, I like to add a little comment. So I'm just going to do the slashes here, which are the start of a comment, T, comma, E, comma, max. So again, a comment is just a little note to yourself. It's not code. It's not something that the Arduino is going to read or the computer is going to read. It's in gray, letting you know that it's just a little note for yourself. All right, so new ping. So now we've created a instance of our ping sensor. We've given it a name, and we've told the Arduino where we've connected it up. So the next thing is the setup, void setup. And here, this is going to be just like with the photoresistor. We just wanted to report the values back to the computer. That's all we're going to do for this sketch. So we'll use the serial command again, serial.begin. So this is starting the communication link between the Arduino and the computer. But instead of 9600, that's too slow for the ping sensor. We need to do another much faster but common speed. And that is 115,200. So 115,200. And that is in kilobytes per second. So that's the speed at which the sonar is going to be sending it to the Arduino. If you get this speed incorrect, then you're going to get a bunch of gibberish as a result. That's it for the setup. I'm going to make sure to get below that curly bracket so that we don't confuse anything, put code in the wrong place. And now the loop, which for the photoresistor was 3 lines. This time it's going to be 2. So void loop, open parentheses, close parentheses, and then open curly bracket. Here, the first line is going to be the line where it listens and then prints that value, prints as in sends that value to the computer. So we use the serial command again, serial.println, like we did before. Oop, I misspelled it, and I knew that because it didn't change its color. I missed a T. Print line, there. Print line, and now what do we want it to print? We didn't. We wanted to print the variable that we created, sonar. But we're going to do something a little special here, because we're not just going to put in sonar. We have an option of telling it what units to put it in. This is something built into the library. You can tell it to give you results in imperial or metric. So we're going to do it in centimeters in this case. So sonar and then dot ping underscore cm. It's a built-in function into the library. That's why it changed its color there. And then after that, it's going to expect a parameter, which we're not going to give it. We don't need to give it a parameter. So that means we're going to do an open and a close parentheses together. And then one more close parenthesis to tie and to close out this parenthesis here. So you've got parenthesis, parenthesis, and then parentheses, parentheses. So I know it's getting a little bit crazy, but we're going to be okay. And then semicolon after that. Now the last line of the loop is just going to be a delay, a longer delay than before to make it easier to read. We'll do 100. And then that's it. So go ahead and get your Arduino and hook it up to your computer. There's a happy little sound. And let's go to Tools to make sure it's got the right port selected. It does, Arduino Uno. And I'm going to go ahead and hit the Upload button. And so, as always, it is checking for errors. If it finds some, it's going to put them in orange here and give you some hints as to what it thinks that the problems are. Usually it's missing a semicolon or misspelling something. And then after that, it's going to compile it into something that the Arduino is going to understand. And then send that on to the Arduino, actually upload. So there it's uploading it. I can see the lights blinking on the Arduino. And now it's done. So everything's good. I didn't get any errors. I can see the transmit light on the Arduino is lit up because it's actively sending data from the pink sensor. Now let me open up the serial monitor here, this button, which will give us the actual values from the sensor. Now, here's something new. Notice, look at the values that I'm getting here, a bunch of backwards question marks. So what is that? Can you guess? If you haven't guessed already, it's because we haven't yet changed it to the speed that we set to. We set it to a unique speed. Before it was at 9600 for the photoresistor. And if you're doing this sketch from the first, then it would probably be the serial monitor would probably be set at 9600 because that's what it is by default. So we need to go in here and change this speed, this baud rate is what it's formally called, to 115/200. All right, now we're getting some actual numbers here. And watch what Aaron's doing. As his hand gets closer, the values are going down. So this is giving us numbers in centimeters. As his hand gets further away, they get larger. So it's working perfectly. So you could use this to measure measure how far away something is, which is kind of cool. So yes, you could make like an electronic tape measure, but you could also use it with maybe something like a robot. Because one of the things that robots need to do if they're mobile is to be able to know if they're going to crash into something or not. Well, if you have one of these on the front, then it can know if it's about to crash into something and take action if it's going to. So that's super fun. I'll bring up a plotter here so that you can see that because graphs are always more fun. There we go. So as his hand gets further away, it changes. So with the with the ping sensor, it's sending out sound, and sound waves disperse like this. So you don't have to be super on point with it as your hand gets further away. As the object is further away, it can see further. It can see a wider. It has like a wider field of view the further away something is. There are other types of distance sensors that use light, and those are more like a pinpoint light, almost like a laser light. So with those, you need to be it'll only see things that are right in front. But if you're using sound, since sound waves propagate outward like that, it can see one sonar sensor is enough to usually help any robot avoid obstacles. So that's really cool. Hope you enjoyed that. Now we'll move on to our third and final sensor. What do you have for us next, Aaron?
So our last sensor, we're going to be using a potentiometer. Potentiometers, typically this is one of the most common types here. It's just a little blue potentiometer. It has 3 pins on the bottom, and the top has a round dial that you can turn to change the amount of current that's going through it. So you can change the resistance through this by moving the potentiometer, or the amount of voltage that's going through it. So we're going to hook up a circuit here, and we're going to make this very fancy and control a LED using our potentiometer, but reading the potentiometer through the Arduino in order to know how high to set the light. All right, so the first thing I'm going to do is I'm going to take the potentiometer. I'm going to set the potentiometer right here on 3 separate rows. And for the potentiometer, I think I mentioned this earlier, it has 3 different pins or 3 different wires. And of these, one gets 5 volts. So this, if you look at the potentiometer, you'll see the side that has these little indentations, little notches, whereas the other side doesn't. So I'm going on the side with the indentations. So the left one of these is going to be connected to 5 volts on your Arduino. The right one is going to be connected to ground. Connect that to ground. And then the middle one is where we're going to be getting our reading of how much voltage is being changed, or basically where this potentiometer is being set to. And to read that, we're going to go into analog 0 over here, because we want to know exactly how much is changing. It's not just on or off, it's a certain value there. All right, so that's our potentiometer. Now, right next to this, I'm going to hook up an LED. And this LED, if you'll remember the 2 legs, there's a longer leg that goes to positive, the shorter leg goes to ground. So I'm going to connect this right here on 2 separate rows. And we're going to first connect the ground up before I forget. So ground is this one right here. That's just going to go to GND on our Arduino board, and luckily you have 3 ground ports on your Arduino. And then the other one of these we're going to connect up to a digital pin, but first we're going to use a resistor. So I'm using a 10K resistor right here, 10,000 ohms, and that should give us enough resistance so we don't burn out the LED. I don't think it would blow up if you connected it directly. It should not, but it would shorten its lifespan. And it's always good practice to have the best practices. So this resistor, the other end of it, that is connected to the longer leg of the LED, I'm going to connect that up to one of my digital pins. This time I'm going to use digital pin 11. And so just to recap this, because this circuit has a little more involved and you can't see it all on board. So digital pin 11 is connected right here to the resistor that goes over to the long leg of our LED. The short leg of the LED is connected up to ground. And then for our potentiometer, we're looking at the side that has the little notches on it, the little indentations. The left side of that has a red wire, any color wire works, but red here, it's going to 5 volts. The middle is going to A0, so we're reading from the potentiometer, and the right side is going to ground as well. So that's our setup. Now let's try some code to make this LED light up or change the brightness based on the reading from the potentiometer.
All right, thank you, Aaron. Okay, now, so let's go back to your Arduino program, your Arduino IDE, and let's begin. So this code is going to be, the longest code that we've written today. So hold on to your hat, because we're going to be doing a couple new things. So in the very beginning, we're going to declare 2 different variables, because we're hooking up 2 things to the board, an LED and a potentiometer. That's pretty reasonable. All right, so we'll start with the LED first. We just have one LED, so I'm just going to call it LED, and Aaron hooked it up to 11. So LED equals 11. And then potentiometer, so INT. Instead of writing out potentiometer, I'm going to write out value for the value of the potentiometer. So the value is going to be, I'm going to not set it to equal anything, because it's going to be changing all the time as you adjust the potentiometer. Now the setup. Void setup. open parentheses, close parentheses, open curly bracket. Here we're just going to use two different lines, and you can probably guess what they're going to be. Well, maybe not for the first one, because for the first one, we're going to have it print the values onto the screen. It's not really necessary for this sketch because we're using a potentiometer to adjust the light, but it's helpful sometimes to see the data coming in. So let's go ahead and do that. Let's open up the serial communication port by typing serial.begin, and open parentheses, and then we're going to go back to 9600 again, default. And that's it for that. So now we need to set the pin mode for the LED. Pin mode. Whenever you use one of the digital pins, you're going to want to do this. Pin mode LED, and we want that to be an output, semicolon. And that's it for that. For the analog pin, since we're just doing it one time in our code, it's not necessary, and it is built for the purpose that we're using it for. We don't have to use pin mode with the analog pin. So we're done with the setup. Below that last closing curly bracket, we're going to type out we're going to do the loop. So void loop, open parentheses, close parentheses, open curly bracket. Here, the first thing we're going to do, unsurprisingly, is listen to the potentiometer. So we made a variable to save whatever is coming from the potentiometer. We called it value. So let's type out value equals, and here's where we do analog read. Just like with the other sensors, we use analog read. Analog read, and Aaron hooked it up to A0. So I'm typing out A0. So now it's going to store the values coming from A0 to the variable value. And now let's have it print that to the screen, to the computer. So we'll type out the statement serial again, serial.println, open parentheses, value. That contains the number that we want. Now we're going to do something new. Just one thing here. We want it to translate the potentiometer value to a brightness value for the LED. There are ranges of data that both can accept, and they're different. So that complicates things. For the potentiometer could be taking in a value, it could be reading a value anywhere from 0 to 1023. But the LED can read anything from 0 to 255. So we need to take those two scales and make one scale out of them. So how do we do that? We do that using a new function we haven't used before called map. We're going to be mapping these values together. We're going to make it so that, obviously they both start at 0, but as they get larger, we're going to make it so that when the potentiometer is turned up all the way and it's reading, and the Arduino is reading it as 1023, we're going to map it so that 1023 is actually 255, which is the brightness setting on the LED. And every number between 0 and 1023 comes from the potentiometer gets reduced to equal to fit on the scale 0 to 255 for the LED. So whatever number is between 0 and 1023, that number will be changed to whatever value is in between 0 and 255, which is what the LED is expecting. So now that that's cleared up and you understand that perfectly, let's write it out. We are going to actually, we created some variables at the beginning. We're actually going to do something we haven't done before, which is we're going to create a variable right now. We can get away with that because we're just using it in one place. So we're going to create a variable and we're going to call it brightness. And it's going to be an integer, so we'll just type out int and then the word brightness. I don't usually use long words, but in this instance I'm just doing it once, and it's very descriptive. So int brightness equals map. All right, so there's your map function. Now, map is going to expect it's going to expect 5 different parameters, but we'll get through this, don't worry. So the very first parameter it's going to expect is the value coming in, the value that you want to change. And that value is actually the variable we created earlier called value. All right, so we'll just type out value. So this is what we want. It's going to take those 2 different scales, the scale from the potentiometer and the scale from the LED, and it's going to take those 2 scales and turn and save that number as value, and then we'll use value later on. Okay, so and then it'll save that as brightness. So value and then comma. Now it's going to expect is the lowest number that it's going to be coming into it. So the lowest number from the potentiometer is 0. Then it's going to expect the highest number coming from the potentiometer. That's 1023. Now it's expecting the lowest number that you want to map it to. So we want to map it to the lowest number that the LED will accept, and that's 0, that's off. And now it's going to expect the highest number that you want to map it to. The highest number then that LEDs will receive is 255. And when I say that the LEDs are going to receive, what I really mean is the lowest number and highest number that you can send to the digital pins. So we're using one of the special digital pins. We're using one of the pulse width modulation pins. Those are the pins that can send out electricity in pulses so that you can do things like fade an LED, get it to be a particular brightness level. And it's going to expect a number from 0 to 255. So to recap, the mapping statement here is going to look at the number coming from the potentiometer. We're telling it the potentiometer, the lowest number of the potentiometer is going to give you is 0. The highest number is going to be 1023. We want it to take whatever the value is and map it to these numbers to fit it on this scale from 0 to 255. Because anything above 255, the digital pin doesn't know what to do with it, and it'll just treat it as 255. So it's going to map those. It's going to map these numbers, whatever this number is coming in from the pot, to this scale, and then save that as brightness. Okay? Still with me? Good. Let's finish that with a semicolon because you're done. You can breathe now. And we'll do our last line for this code, which is very simple, where we actually tell it to turn on the LED to a particular brightness. So here we use a function called analog write, which I don't believe we've used before. Analog write. So we've used analog reads, but now we're going to have it do analog write. So even though it's one of the digital pins, this is how you get it to use the pulse width modulation. So analog write, it's going to expect 2 parameters. Which pin you're talking about? We're talking about the LED pin, pin number 11. And then it's going to expect the brightness value, which we've saved here as brightness. So you just type in brightness. All right. And then your closing curly bracket should be right here. It ties into the beginning of the loop. And you should be good to go. So let's go ahead and hook this up and then see if it works. Should have moved it. There we go. Okay. So it's hooked up. I'm going to make sure that it's reading the correct port. It is. I'm going to go ahead and send it. And so as usual, it's going to check it for errors. If it doesn't find any, then it's going to compile it into something that the Arduino is going to recognize and then send it on. And then now it's uploading it. If you'd like to do the honors, Aaron.
Yes. My favorite part, controlling the potentiometer. So you may notice it's very dim right now. As I turn the potentiometer, it is getting brighter and dimmer. So hopefully you can see that as bright as it goes, and then it slowly gets dimmer.
There we go.
All the way off. So that's mapped perfectly.
Perfect.
And we can also see these values in the serial monitor, just like we did for our last 2 resources. We were printing them, we just have to change the baud rate back to 9600, which we use for this. We set that up at the beginning. And so hopefully that'll give us values. So you can see these values great. And these are what the potentiometer is reading. So you see it goes up, all the way up, 1023, all the way down to 0. And then it's mapping it over to the LED. That's a neat little circuit, neat little sensor. And you'll see potentiometers used on a number of different things, just like the other sensors we talked about today. And so now, hopefully, you have all the resources, all the knowledge that you would need to be able to create a project on your own. We have a fun episode coming up where we're going to put all these resources together and make a robot.
That's right. Yes. So we've used parts that can move. We use parts that can sense. We've used parts that can send data to your computer. We've used parts that you can interact with. There's a lot that you can do with it. There are many other different parts that you can get. Your kit would have included many, and it probably came with a tutorial as well. So we hope that this helped you feel a little bit more comfortable with the board and with the parts that can come with it. And like Aaron said, the next episode is going to be the final episode where we actually put something really cool together. So we hope that you all join us in that. Thank you again. My name is Matthew. This is Aaron, and this has been an Arduino Quick Setup Guide here at the Visual World Investigate Lab at the North Carolina Museum of Natural Sciences in downtown Raleigh. Until next time, thank you.